today we are going to start with the last topic of the chapter, that is the partition coefficient. Okay, this is the last topic of the chapter. So tomorrow your test would be from the equilibria. Okay, so you should prepare it well. Uh, so let's start with the partition coefficient. Partition coefficient. Partition coefficient that is denoted by the symbol KPC. Okay. The word P that is partition and the C that is coefficient. Partition coefficient. Okay. So what is the partition coefficient? To make you people understand about it, uh, let me give you a single example. Then I'm going to brief this one for you. It's actually partition coefficient that is actually the ratio. Okay, so the ratio is always between the two things with the same units. Okay, so the two values with the same unit. Okay, so it is the ratio. Okay, of which thing? Of the concentration of a solute. Okay, so you got the solute concentration, and you know that the units of the concentration, they are always mole per dm. Okay, so it is the concentration of the solute in two different solvents. This one, let's suppose in solvent 1. Okay, and this one that is we should write this one as solvent 1, and this is solvent 2. Okay, in such a way that the two solvents, they are immiscible in each other. Okay, I'm going to give you one example. Let's suppose you got the sugar. Okay, so you dissolve the sugar in the water. Okay, so you just stir it well. The sugar that disappears. Okay, so you people are unable to see the sugar now. Now what you do? You add the petrol on it. Okay, sugar is soluble in water as well as in the petrol. Now when you add the petrol in the solution of the sugar and water, and you just shake it well, so what would happen? The sugar that is soluble in both solvents. So what would happen? The petrol will extract the sugar from the water, even though it is dissolved. Okay, so it will dissolve some amount of the sugar inside it. Okay, so now the concentration of the sugar in the water and in the petrol, its ratio that is called as the KPC, in such a way that the petrol and water, they are insoluble in each other. They do not dissolve in each other. The two solvents, they are immiscible, they do not dissolve, but the solute is soluble in both the solvents. Okay, and the concentration of that solute in two different solvents in such a way that the two solvents, they are immiscible in each other. So that is called as the partition coefficient. Everyone got it? Yes. Everyone got it, beta? Okay.
Yes, sir.
I'm going to write down the definition of it. First of all, write down its definition. The ratio of the concentration of a solute in two different solvents in such a way that the two solvents are immiscible. Immiscible word means insoluble. Okay, in each other. Is called partition coefficient. Okay. So the partition coefficient, my dear, it is the ratio of the concentration of a solute in two different solvents in such a way that the two solvents, they are immiscible in each other. So that is called as the partition coefficient. Okay, so let's suppose we got uh, an apparatus up here which you people have used in your O levels. So this is an apparatus. It has got a tab. Okay. So this apparatus that is called as the separating funnel. Okay. So it's a separating funnel. And separating funnel, my dear, it is used to separate the two immiscible liquids. Okay. If the two liquids they are immiscible and you want to separate them, so you have to use the separating funnel. Now what I'm going to do, I'm going to put 100 cm cube of water inside it, first of all. 100 cm cube of water. Okay. Now everybody just listen it carefully, beta. I've taken the 100 cm cube of water. The second thing, I'm going to add 5 gram sugar in it. 5 gram sugar. Okay. Now what I'm going to do, I'm going to put the bung on it. Bung is actually the stopper. Okay. And just shake it well. So when I'm going to shake it well, what would happen? This 5 gram sugar that would dissolve within that 100 cm cube of water. Okay, so you people are unable to see that 5 gram sugar. So when it would disappear, now you open this bung again. Bung is the stopper. Okay, this is the stopper. So you open this stopper again, and now what you do, you put 100 cm cube of hexane inside it. 100 cm cube of hexane. You know that from pentane to decaying, all these things, they are the part of the petrol. Okay, so in other words, I'm going to put the petrol up here. Okay, so I've taken the hexane, 100 cm cube of hexane up here. Okay, again, I'm going to put the bung on it, put the bung, and just shake it well. So when I shake it well, so what would happen? This hexane that is going to basically draw some sugar in it. Okay, let's suppose it draw 3 gram sugar inside it. Now out of 5 gram, 3 gram has been extracted into the hexane, and here only 2 gram of sugar is remaining in the water. Okay, so now I want to find out the concentration of the sugar. So sugar concentration in hexane. So what it would be? 3 gram of sugar has been extracted divided by the total volume of the liquid, that is hexane is 100 cm3. So if you divide it, you will get 0.03 gram per cm3. Okay. So these are the units of the concentration as well, because this is the ratio. The units at the top and units at the bottom, they are always same. So you don't need to change it in mole per dm cube or gram per dm cube or gram per. You can use any unit because units would be cancelled. Okay, so you don't need to change it. If the two units in both cases they are same, no need to change it. So we can use this unit, gram per cm cube. Gram per dm cube, gram per cm cube, mole per dm cube. All these are the units of the, come on, concentration. Okay. So now the sugar concentration in the water. Okay. So in the water you got 2 gram of the sugar, and how much water you got? 100 cm. So it would be 0.02 a gram per cm. Okay. Now the question produces, my dear, which solvent you should take as a solvent 1 and which one you should take as a solvent 2. So keep remember, whatever the solvent you have taken firstly, which solvent you have taken first? Water. So water would come in denominator, and the other solvent you have added after the water, so that would come as a solvent too. So here you could put the value of the Kpc. So Kpc is the sugar concentration in hexane. It would come in the nominator. Sugar concentration in water. So that would come in the denominator. Okay. So now put the values of here. Hexane, that is 0.03 and this is 0.02. So if you solve it up, what you will get? 1.5 or 1.33? 1.5, I think. Is it? Yes, sir. 1.5. So this is the value of the Kpc for this one. Okay. Now, my dear students, the next thing, if the value of the Kpc that is equal to 1. So, yes, Maria, can you please tell me when you get the answer 1 for the concentration of the solute in two different solvents? Come on. When you get the 1 answer? Any guess? Yes, Javier Shehzad, have you got an idea, beta? When you get the Kpc?
Sir, same concentrations.
Thank you so much, my dear. If the concentration of the solute is same in both solvents, okay? So if the concentration of solute is same in both solvents, okay? So if you got the value 2.8 up here and you got the value 2.8 up here, both will be cut and you will get one answer. Okay. So if the concentration of solute is same in both solvents, okay, and if the value of the Kpc is greater than 1, yes, Fatma, can you please make a guess when you get the value more than 1? If the answer is more than 1, what does it mean?
When the solute is
Yeah, exactly.
different both sides.
Exactly. The solute is more soluble in solvent 2 than in solvent 1. So the concentration of the solute is greater in solvent 2 than in solvent 1. So then you get the greater answer. Let's suppose here you got 8 and here you got 5. So if you divide it, you will get the answer greater than 1. Okay. So if the concentration of solute is greater in solvent 2 than solvent 1. Okay? Okay, my dear students, if the value of the Kpc that is less than 1, so of course less than 1 mean that this answer in the denominator that is larger. So it means the concentration of the solute is greater in solvent 1 than solvent 2. Okay, so the concentration of solute is greater in solvent 1 than solvent 2. Okay, and Kpc has got no units, keep remember, because the things at the denominator and denominator they are same, so that is why it has got no units. Okay. Okay, my dear students, now I'm going to write down a question up here. This question is very lengthy. Okay, so you people have to write this whole question, and after that, I'm going to solve its part one by one. The two part, it got three parts. The two parts I will do it for you, and the third part you have to do it by yourself. So please just note it down and just listen it very carefully. That how you have to solve this question. Okay. So let's start, my dear. I'm going to write down the question up here. The question is, okay, guys. So just write down this question first of all, and then we are going to solve it. So this is the same thing. Same thing you should write up here. Okay, guys, I think everyone has written it. Now, just listen this question. What is meant by this question? I'm going to read this question for you. Everybody just listen. He's saying an organic compound is 5 times more soluble in solvent X than water. Okay. So what is meant by that? I'm going to tell you a little bit later. So basically, in this question, the solute is actually the organic compound. Okay, organic compound. You have taken 10 gram of organic compound. The first solvent you have taken, that is 100 cm cube of water. Okay, so this is the first solvent. So it means if you want to find out the Kpc, so the formula of the Kpc, that is equal to the organic compound concentration, organic compound, its concentration, just write it at the top and just write it at the bottom as well. Organic compound concentration. Now, if you read this question, the first solvent you have taken, that is the water. So in the denominator, you should write the water, and after that you have added 100 cm cube of solvent X. So solvent X is present up here. Now, if you read this first part of the question, you will understand it. He's actually saying you an organic compound is 5 times more soluble in solvent X. Solvent X is this one. So it's 5 times, and this one in water is 1 time. So if you divide it, what the answer you got? 5. So this whole story means that the value of the Kpc, that is actually 5. Did you get it? Sometimes he make you confused. He did not directly give you the value of the Kpc. He could write these type of the term, that this compound is more soluble in that solvent than this one. Okay. Let's suppose he could write this like that. An organic compound is uh, 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 5 times less soluble in solvent X than water. So it means less than. So it means this one is 1 and this is 5 times now. Now if you divide it, this would be the value of the Kpc. Did you get it? So he can give you the values of the Kpc in this manner as well. But most of the time, 98% chances are there he's gonna give you the value directly Kpc. Okay, but 2% he could give you like that. So that is why I have written this kind of the question. Okay. So the value of the Kpc is 5. Keep this thing in your mind. Okay. Now what he has done, basically he has taken the 10 gram of organic compound, he dissolved it in 100 cm cube of water, and now he adds the solvent X inside it by 3 modes, 3 ways. What are those 3 ways? The first way is he added 100 cm cube of solvent X all together. एक बार ही डाल दिया सारा 100 cm क्यूब ऑफ सॉल्वेंट है, तो पूछ रहे हैं कि अगर वो एक बार ही डाल दे, वन पोर्शन इकट्ठा डाल दे, so what amount of the organic compound could be extracted by this solvent X. And then in the second part he's saying that firstly he adds 50 cm cube of solvent X, just shake it, and then after that he adds 50 cm cube of solvent X and then shake it. So what amount of the solute is going to be extracted by these two portions? And in the third method, he's gonna say you that 4 portions. He added 100 cm cube of solvent X, not more than that, but added these 100 cm cube of solvent X by 3 ways. In the first part, he added the 100 cm cube, only one portion altogether. In the second one, he added 100 cm cube of solvent X, but step by step. Firstly, he added 50 cm cube, and then he added 50 cm. And in the third one, he added 100 cm cube of solvent X by 4 portions, 25 cm cube portion each. Did you get it? So these two, I'm going to do it for you, and this third one, you have to do it from your home. Okay, so everybody just listen it carefully. Okay, this is a difficult thing. I'm telling you again, this is not easy. Okay, everybody just listen. So first of all, we are going to do the part 1. Okay, in the part 1, if one portion of 100 cm cube of solvent X is added. Okay, my dear students, everybody just listen. Your focus should be up here. First of all, I'm going to suppose, what the thing I'm going to suppose that the solvent X extract organic compound. So the amount of organic compound the solvent X extract, that is A gram. A gram. This thing I'm going to suppose. Okay. Now the organic compound, I'm going to denote the organic compound with OC. OC means organic compound. Okay. I'm not going to write it again and again. Organic compound concentration in X, that would be A gram he has extracted, and what the volume of the solvent X you added, 100 cm. Okay. Now the organic compound concentration in water. Okay. So you got total 10 gram of the organic compound. Out of this 10 gram, A gram has been extracted up here. So how much is remaining in the water? 10 minus A. So 10 minus A over water is 100. Now put these values up here in this question. So the value of the KPC, that is 5. Organic compound concentration in X, that is A over 100. Okay. And this one divided by 10 minus A over 100. So 5, that is equal to A over 100. This one would be multiplied, and denominator would become nominator, and nominator would become denominator. 100, that would be cut. So if you solve it up, A over 10 minus A, if you find out the value of A, that is 8.14 gram. 8 point, no, just 8 point something, just calculate it here. मुझे लगता है कि क्लास खत्म हो गई है. 8.33 gram. So it means the solvent X extract 8.33 gram out of 10 gram, and in the water how much is remaining? 10 minus 8.33, that would be 1.67 gram. 1.67 gram of the organic compound that would remain within the water. Did you get it? Online students, did you get it or not? Fatma, Hadia, Maria, Muskan, Yahya, beta?
Yes, sir.
Yes. Yes, sir.
Okay, my dear, now I'm going to do the second part. In the second part, the two portions are added right after one another. Okay, so here the first portion is added. The first portion of 50 cm cube of solvent X is added. Okay, and then the second portion of 50 cm cube of solvent X is added. Okay, guys. Now the organic compound concentration in X. So I'm going to take, suppose that solvent X extract organic compound B gram. Let's go B gram divided by what is the volume of the X you have taken, that is 50 cm cube this time. Okay, and now the organic compound concentration in water, that would be 10 minus B over water is 100. Water volume is not decreased. Now, if you put these values in this formula, so 5 that is equal to B over 50 divided by 10 minus B over 100. So if you solve it up, you will get the answer 7.14 gram. So this is the amount of organic compound extracted by 50 cm cube of solvent X. Now anyone could tell me how much is remaining in the water? Okay, water remaining. Come on. How much amount is remaining in the water? 2.86. 2.86. Now this value you have to use for your next calculation. Now water has got 2.86 gram. Okay. So in this part you again take organic compound concentration in X. You could take it as C gram. Okay. C divided by X is again 50. And organic compound concentration in water. Okay, now water is not having the 10 gram, water is now having 2.86 gram. So 2.86 minus E over 100. Okay, so if you put these values in this formula, so 5 is equal to C over 50 divided by 2.86 minus E over 100. So if you solve it up, the value of the C that would be 2.14 gram. Now the total extraction that has been carried out by 100 cm cube of solvent X, that is greater than the first portion you have done. If you do it, 2.14 and 7.14. If you add it up, it would become 9. I think this is 9.28 gram. Okay, 9.28 gram that has been extracted. But if you take 100 cm cube of solvent X altogether, so you will get 8.33 gram extraction. Did you get it? Now if you add 4 portions, 25 cm cube, okay, right after one another, so it will extract more organic compound. Did you get it?